start with number 1 here on the vector assignment. All right. So I got a length of a mountain slope this, makes an angle of this with the horizontal. What is the height of the mountain relative to the base? So this is problem number 1. And I'm going to do my vector diagram. So I need a vector diagram for my y here. So my vector diagram is going to have the slope of my mountain. And this is my y, yep. My y is a vector diagram. I have different colors, so I'm going to use different colors to show my components. You don't have to, but. And now I'm going to fill in that information they told me, which was, let's see, the length of the slope is 2,890 meters. Notice that's in red, so that's different for everyone, right? What's yours, Sarah? Okay. 2,890 meters, that's mine. And then it tells me it makes an angle of 12.6 with the horizontal. So it does matter. It has to be between the hypotenuse of the triangle and the horizontal component. Okay, but are you asking whether you drew it facing right or left? No. No, it has to be with that horizontal versus the hypotenuse. Then it would go up top. Yeah, you got it. Good. All right, so that's my vector diagram. That's my how, my y for it. Now my how, I have a right triangle, and they're asking me what is the height of the mountain relative to the base. So they want to know side y here, and I look at that side and I say, oh, that's opposite my angle, and I know my hypotenuse, and I know my angle, and then I think about, do I know a ratio between opposite, hypotenuse, and angle? And I think SOHCAHTOA, because it's a triangle, and I think of SO, which is sine of the angle equals the opposite over the hypotenuse. And now I fill in what I fill in what I know. Sine 12.6 degrees equals y over 2,890 meters. Oh, I can solve that for y. 2,890 meters times sine of 12.6 degrees. Probably should put parentheses around it. Equals y. And now I grab my handy-dandy calculator. What do I have to make sure that is true about my calculator before I do this? Huh? That it's in degree notation, so that'll do it every time, because I'll tell you, 12.6 radians is like twice around the circle. So I get 630 meters. You hit mode, arrow down to the word degree, and hit enter. It is, let's see if I get it right. 630, mid-answer. Come on, green check. Come on, green check. Come on, green check. Yay! All right, we're going to get the y of number 2 done before we go to lunch, folks. And they have this sheet. It's running at this speed in this direction, 80 degrees north of west. and they want to know the components north and west. So, north of west is going to be somewhere in this direction. And west is here, and it's telling me I'm pulling this, how many ever degrees it is, 8 minus 80. 80, I'm starting at west, and I'm pulling 80 degrees north. That's north of west. Yes. And so that's my vector, and it tells me its magnitude is 16.5 meters per second. Technically, that's all I would really need for my Y. But since you're finding the components, I would suggest drawing the components in there. All right? And labeling them, I'm going to call this one north and this one west, just so I remember which one's which. And I'll tell you the most common mistake I see on this problem, and I've seen it about 5 times this year already, is people will figure out the west component and put it in for the north. Figure out the north and put it in for the west. They'll exactly swap them. So just be careful of them. And that's why I'm going to label mine N and W. So I make sure I don't do that. Right? Let me make sure I got everything right. North of west. Yep. So now I'm going to, which one do you want to find first? North or west? North. Okay. So north is opposite. So I think about, I think so. So I'm going to say, I'm going to start up in here. Sine of 80 degrees equals opposite, which is north, over my hypotenuse of 16.5 meters per second. Rearrange that, I get 16.5 meters per second times sine of 80 degrees equals n. And then I can numerically solve that. I'm going to do my west now. Little dotted line here. And west is adjacent. So what part of it do I think of? Ka, right? Cosine. Cosine of 80 degrees equals adjacent west over hypotenuse, 16.5 meters per second. Make sure you guys look this weekend in WebAssign for an updated equation sheet with a better SOHCAHTOA reference in it. And rearrange this, 16.5 meters per second, cosine 80 degrees equals W. Ha! And I finished it before lunch. No comments on my Friday. Here we go. So number 5 here. And nicely, if I pick the right one on the first part here, then I have my Y already done for me. All I gotta do is copy it in there, right? So I'm looking for an RA vector that points below the positive x-axis. So I'm looking through my 4 diagrams. They all point below the x-axis. Good. And then down, I'm looking for a RB vector that points above the positive x-axis. And they all do. Okay, so now I'm adding those two together. So I'm looking for an RA and an RB that are in tip-to-tail arrangement. So in the upper left corner there in tail-to-tail, throw that one away. I know that's crazy. Upper right corner, tail-to-tail, throw that one away. Okay, so I'm going to forget about those two altogether. And in here, in the bottom left corner in mine, I have tip-to-tail. The tail of RB is on the tip of RA. And I have tail-to-tail here. Oops, I must have misread one of them. Oh, it's the upper left, upper right also have tip-to-tail. So it's going to be the bottom left or upper right. And, oh, that's right, it's tip-to-tail and then tail-to-tip. So it's like, remember, it's like you and your friend walking. You got to start at the same place. They're going to take a path around the tree, you're going to go straight. If I do the top right, my friend and I both get up to the same place. The bottom left, we don't. So it's the top right is the correct choice. I'm going to grab that so I don't have to redraw my ray diagram, my vector diagram. These arrangements, they may swap the position of them. I can't remember. But there's only so many possibilities. Remember, it's the things in red that are different for everybody. All right? So we're doing number 5 here. And now let me transfer over some of my other facts here that they tell me. That's the one I picked because it's RA to RB is in tip to tail, and then RC goes from tail to tip. Remember, the rule is tip to tail, tail to tip. Let's see, they tell me that the angle below the axis is 20 degrees. So this little angle in here, they tell me, is 20 degrees. And it is, mine is 48 meters long. Notice that number's in red, so that's different for everybody. So my RA, I'm going to replace my RA by 48 meters. Then, see what else they tell me. They tell me that RB is 53 degrees above the x-axis. So if I do a little dotted line here like this, this would be 53 degrees. And they tell me the length is 75 meters. Huh? They tell me the angle between the x-axis and vector RA is 20 degrees. I think that's the same for everyone. Okay. No? Well, we may all have the same graph. Because look at your numbers. Which numbers are in red? The magnitude of RA and the direction of RB, but I bet that all of the RBs are close to 53. Right? Yeah. But not exact. So. All right, and I want to find out R sub C. Well, my approach here is this type of thought. All right? Let's say I had these numbers. I wanted to add 274 plus 59. Right? If I wanted to add those two numbers together, and I didn't want to use my calculator, I may break them into numbers. I'm explaining my thought process here, right? I'm going to break these into numbers that make more sense to me. I'm going to break this into 250 plus 24. This is plus 50 plus 9. So I've taken and made components of those numbers. And then 50 plus 250 is 300. Plus 24 plus 9 makes sense to me, it's 33. So my answer ends up being 333. Because if I take adding 274 and 59 together, I can't do that in my head. My head starts to hurt, especially on a Friday afternoon. But I know I can break 274 down into its components, its parts. If I add up the parts, I get the new whole. I made these numbers up to prove a point. It made sense at 7 in the morning, right? I made them up. He made them up to prove a point. The point that I'm trying to prove here, maybe I'm not doing a good job proving it, is that if I take the parts of RA and RB, add those together, I'm going to get the parts of C. If I take the parts of RA and the parts of RB, add them together, I'm going to get the parts of vector RC, and then I can get vector C. That's my point. What 19? That's a 20. It's an angle mark with a 20 next to it. Oh, I see what you're seeing. Yeah, it's an angle mark with 20 next to it. To indicate that that angle is 20 degrees. Right. Okay. They told me in my problem, read your problem. They told me that vector RA was at 20 degrees below the x-axis. So this horizontal line that's labeled plus x is called the x-axis. So from that line to vector RA is 20 degrees. Okay. They told me my vector RA had a length of 48 meters. So, yeah, good. So I labeled the length of my RA 48. Am I good? Do I need to do it the other two, or? I'm on number 5. I already did number 2. Yeah, number 2 is the one I did just before lunch. I did. You're right. I didn't plug my numbers into the calculator, but I did all the steps. That's all that was left. What I'm saying is, if I take my 2 vectors that I want to add together, and I break them into their components, I'm going to add their components together, and I'm going to get vector C. I know you don't get it yet because I haven't been able to progress that far yet. You ready for me to go to the next step? Okay. Tell me when you are.
I have this all down to my problem, but I don't know how you I don't understand why you got these numbers. Where do I
I made up these numbers. Folks, since this comes up a couple of times, please stop what you're doing. Listen to me say this, because I've written it and I've said it, and I'd like to move beyond it. I figured you guys know how to do addition with numbers. So I gave an example of taking a number, breaking it into parts, and adding the parts together. Because that's what we're going to do with the vectors. I am sorry, I didn't think breaking numbers into parts and adding them would cause so much stress and confusion. But it's an example of what we're going to do with the vectors. We're going to take the vectors, break them into parts, like I broke the numbers into parts, add the parts, and then get the whole number back. That's the idea. That's why I did this as a simple example of what we're going to do with vectors. That's the whole idea behind this black thing that I made up to prove a point. And it didn't work. And I learned that, and I'll never do it again, I promise. In fact, it doesn't exist. There we go. All right, ready to do the problem? Here we go. So, my first step is going to be to take the 2 vectors that I'm trying to add together and break them into components. I'm going to do that. Here's vector RA, which is 48 meters long. I'm going to break it into a horizontal component and a vertical component. And I know that this angle is 20 degrees in there. So if I want the adjacent side, I'm thinking SOHCAHTOA. I'm going to think cosine. I'm going to do 48 meters cosine 20 degrees. And that will give me the adjacent side. Yes? Refer back to problem 2 or problem 1 if you, how I got the 48 cosine 20. To get the opposite side, I'm thinking sine again. So on the opposite side, I'm going to get 48 meters sine 20 degrees. Notice, which direction does the opposite side point? Huh? Downwards. Downwards. It's a good thing to notice. It's a good thing to notice. I'm going to do the same thing for my other vector here, r sub b. In fact, I'm going to move this over. Move that over so that I can do r sub b over here. I'm going to draw r sub b. I'm going to draw its components. They tell me this is 75 meters long. This is 53 degrees. So I look and say, oh, the adjacent side there for 75 meters cosine 53 degrees. And the opposite side, I get 75 meters sine 53 degrees. Notice that the horizontal points to the right and the vertical points upwards, right? So now what I'm going to do, since I've taken my two vectors and broken them into parts, is I'm going to add up those parts. And those parts will add up and be the parts of my final vector. So I'm going to take the horizontal part of A, which is 48 meters cosine 20 degrees. I'm going to add to that the horizontal part of B. How do I add two vectors together? How do I arrange them? Tip to tail, right? So I'm going to put the horizontal part of B right here. That's 75 meters cosine 53. Of course, you could work these out to their values, right? Now, because I have the blue pen, I might as well continue in the blue, right? Move this down a little bit. Now I'm going to put my vertical vector here from B, which is 75 sine of 53 degrees. Does it matter if I add A plus B? Is that different than B plus A? No, right? We learned that the other day, and you learned that in math, hopefully. So there's my B vertical. I'm going to add to that my A vertical. Oh, my A vertical doesn't go up, it goes down. So it's like that. And it has this value of 48 meters sine 20 degrees. So my final C vector starts here, goes to there. Why does it go down? Because when I'm arranging vectors to add them, I have to put them in tip to tail. And as I think you pointed out, the vertical part of my vector A goes downwards. So I arrange them tip to tail. And then I have a right triangle here. There's theta. There's my right angle. And now I'm going to figure out the sides of my right triangle. All right? So I took my vectors, broke them into parts, combined the parts, and now I'm going to try to add those new parts to get a whole number again. Excuse me. So, let's see. I'm going to redraw this just one more time. I need that length. That length, where's my pen? Is going to be the red 48 cosine 20 plus 75 meters cosine 53. So I'm going to do that 48 cosine 20 plus 75 cosine 53, and I get 90.2414 meters. I have more digits, but I'm just keeping them in my calculator. Yes, see how the vectors point in the same direction? We're adding them. And then I want to combine these two vertical ones, and I notice that it goes up and then comes back down, so it's going to be plus the blue minus the red. So 75 sine of 53 minus 48 sine 20, I get for mine 4807 meters. And now I need to figure out RC and theta. Now that I've figured out those, which one do you want to do first, RC or theta? RC. So that's the hypotenuse of my right triangle, right? What's my ratio that relates my sides to the hypotenuse? Pythagorean theorem. Pythagorean theorem says that 90.2414 meters squared plus 43.4807 meters squared equals RC squared. Most common mistake here will be forgetting to take the square root of what you end up with in your calculator. Lots of people are good at that. Ooh, that's not good. And second square root, second answer. I get 100 meters. Jen, could you do me the favor of putting in 100 meters there? And I'm going to submit. I think I missed it. Submit. Oh, never mind. It's doing it. I see the little green swirly. And yes, I got both those. You know, if you guys click on the numbers up there, it flips you right to the problem, right?
Wow.
It's one of those tricks. If on your problem list at the top, you click on the number of the problem, it flips you right down to that problem. One of those hidden tricks. So now I need to find out theta. What relationship relates the opposite side to the adjacent side to the angle? Tan. Toe. Good old toe. It says tan of theta equals opposite 43.407 meters over adjacent 90.2414 meters. But I don't want tangent, I want theta, so I got to do the inverse or arctan of both sides. That is what the name of the inverse or arctan function is. No, you use the shift key on your calculator to get the inverse tan function or the arctan function. So I'm going to do that on my calculator, and I'm trying to get the calculator app up here so you can see that. But I don't have it yet. I want to see if I get this right. It's been a long problem. Well, mathematically, to get anything onto the other side, to get something out of a function, I have to do the reverse function. Like if I have two numbers added, to get one of those on the other side, I have to subtract. If I have two numbers multiplied, I have to divide. Well, when I have a tan theta, to get theta out, I need to do the inverse function of tan, which is either known as inverse tan or arctan, and can be symbolized either by tan to the negative 1 or a tan, depending upon your marking system. So if you look on your calculator, you'll notice that the shift function on your tangent button either has an a tan or a tan and a minus 1. That's known as the arc or inverse tan function. And that's what I need. That's what I'm symbolizing there. Theta, I get 25.7 degrees. And Miss Jen, oops. Hold on. Click. Oh, wait, I got it. There you go. Now click. 25.7.
Okay.
Submit answer, yep. I hope I got it right. I hope it. Yay! I got it right. Yeah, let me pause.